question 6 of the Optical Phenomena Photoelectric worksheet, which is taken from the February-March 2010 paper. During an experiment, and in any exam you're going to get at least one experimental skills question, which is what this is, to determine the work function of a certain light of different frequencies was shone on the metal of a surface. Something's wrong with the grammar, but anyway, and the corresponding kinetic energies of the photoelectrons were recorded as shown in the table below. So what this is basically saying to you, they wanted to know what the work function of a certain metal was. So they took the metal, they shone a whole bunch of light on it, and they recorded the energies of the photoelectrons. Don't stress too much about how they did it, but that's what they did. Then they say, define the term work function. Well, we've done this already, and by now this is hopefully, if you've done enough of these questions, this is just normal now. So it's the minimum energy required to remove or eject an electron from the surface of a metal. So that's easy. Now they say use the data, that should say data, not date, data, in the table above to draw a graph of kinetic energy versus frequency on the graph paper provided. Now we need to be careful. What is the independent variable and what is the dependent variable, okay? Because this actually is quite important. So we're going to use the graph paper. Now I've cheated a little bit, okay? I'm not going to draw the graph because it'll take forever, but you really need to spend some time doing this. When you get given a table like this, the first thing is always the independent variable. The second one is the dependent variable, which means the first thing that we've got here is your x-axis. Second thing is your y-axis, okay? And here, we need to look at what happens when we plot it as to whether it's going to be a curve or a straight line or anything like this. And this is going to be a straight line, okay? A curve doesn't make any sense. We know there's a proportionality between frequency and kinetic energy. If frequency increases, the kinetic energy increases. So it's fairly straightforward. Now remember, this is an accurate graph. So there's a couple of things you need to have. So I did cheat. Okay, here's the graph. And this is what the memo gave us. So first of all, I need a decent heading. Graph of dependent versus independent. Okay, first of all. Secondly, labels kinetic energy times 10 to the minus 19, frequency units times 10 to the 14. Now, what they did when they gave you this is they gave you the numbers quite nicely. So forget about the times 10 to the 14, the 10 to the minus 19. You've put that in the units. Use these like normal numbers to plot the values, okay? And you plot the values and they work this one out quite nicely, and the graph is actually this point. That's what you would have originally plotted, okay? And your graphs, of course, is for having an appropriate scale, a scale that makes sense, that uses as much of the graph paper as possible that you were given, plotting all the points correctly, and then drawing a line of best fit, okay? We don't draw in dot-to-dot lines. It's always a line of best fit, going through as many points as possible. This takes time. This is easy marks as long as you take your time doing it. Don't rush this because it's a waste of time. Don't. You're probably going to have to find information from it with this sort of question. So then they say to us, extrapolate. That just means take it backwards. Extrapolate your graph to cut the x-axis. What is the frequency at the point of intercept? So they're going to, okay, now take your graph, use your pencil and draw it backwards. That's this point. Okay. and they want you to read it off. Now, the official memo said 5,4 times 10 to the 14 hertz. There's a little bit of leeway in accuracy here. Okay, a little bit of leeway. Obviously, if your graph is completely inaccurate, you're not going to get this mark. So you need to be accurate. Don't throw away marks for something silly. But then they want to know what term is used to describe this frequency. Look at your graph. At this point, the kinetic energy of my electrons is 0. That makes this your threshold frequency. Okay? When we have threshold frequency, okay, that's the minimum energy. And all it does with threshold frequencies, get the electrons to the surface. They don't go anywhere. They've used all the energy from the photon just to get to the surface. So that's where they'll stay. Then they say use your graph to determine the work function of the metal. Well, this is the point. I know now what threshold frequency is. So work function is HFO 6,63 times 10 to the minus 34, 5,4 times 10 to the 14, and obviously we take down whatever your answer was in the previous question. And there we go. Really not so bad. It's a skills question because of drawing the graph. And obviously all the questions that follow the graph depend on the accuracy of your graph. Very important. Graphing skills, being able to interpret and draw graphs, very, very important.